Hello students. Today we are going to have the first of hopefully several or many flipped chemistry lectures, and today's topic is scientific notation. You may ask yourself, why do we need to understand how to use scientific notation? Well, in chemistry, we often work with extremely large or extremely small numbers. For example, 1 gram of hydrogen atoms contains about this many very large number of atoms. And likewise, the mass of 1 atom of gold is this extremely small number of grams. It's really cumbersome and often pretty boring to have to write out many such numbers when working problems in chemistry. So we use scientific notation as a method for conveniently expressing these very large or very small numbers. So what is the basic method for writing a number in scientific notation? Each value can be expressed as the product of two numbers. And by product, I mean you have to multiply these two numbers together. So the first number we call the coefficient. And I'm going to use m to represent the coefficient. And that coefficient is multiplied by 10, raised to a power. And I'm going to use n to represent that power of 10. We call that power of 10 an exponent. So in this example of that very large number of hydrogen atoms, we would write this in scientific notation as 6.02 times 10 raised to the 23rd power. So once again, this would be our coefficient. And this would be the exponent. The rule to remember is that in scientific notation, the coefficient is always a number greater than or equal to 1, but less than 10. That is, the coefficient lies within the range of 1, and it can be 1 and less than 10. So somewhere in that range. So a positive exponent indicates how many times the coefficient is multiplied by 10. For example, if we write 2 times 10 to the 3rd power, it's really saying that you multiply 2 by 10 times 10 times 10. This is the same as writing 2 times 1,000. And if you multiply that out, it's 2,000. Okay. A negative exponent tells us how many times the coefficient is divided by 10. For example, if we have the number 5 times 10 to the negative 3rd power, what this is really telling us is this is 5 divided by 10 divided by 10 divided by 10. Okay? This is really the same as writing 5 over 10 times 10 times 10 in the denominator. Okay? And in other words, it's the same thing as 5 divided by 1,000, which, if you divide this out, is the decimal fraction of 0.005. So how do you convert from standard or expanded form numbers into scientific notation? So there's two types of numbers. There are numbers larger than 1 and those that are smaller or fractions of 1. And we'll deal with the larger than 1 number case first. For example, I'm going to work on how to write this number 634 million in scientific notation. The first thing we're going to do is to place a decimal point at the end of the number. Now, there is an invisible decimal point there. It's always been there. We just don't normally think about it. But we're going to make this very visible by putting that decimal point there. The next step is to move that decimal point from the end of this number to a spot in the number that's going to give us that coefficient that is between 1 and 10. Well, what number? 63 wouldn't be between 1 and 10. 634 wouldn't be 1 and 10. But if we put the decimal point right here, that gives us a number between 1 and 10. So that's how we decide where to put the decimal point. Okay, the next step is to count how many times we move that decimal point. We moved it 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, so that gives us a coefficient of 6.34 on all these zeros. We're going to talk about those zeros in a moment. I think I have one too many zeros in there. There we go. And the 8 times that we move that decimal point tells us that our exponent is 8. And because this is a really big number, we know that we have to have a positive exponent. So the last thing we're going to do then is just not worry about all those zeros. We're just going to drop those. So our final answer is 6.34 times 10 to the 8th power. Okay, for the example when you have working with fractions of 1, and here's a number, we'll write 0.0000921. Okay, how would we write that in scientific notation? Well, once again, we've already got a decimal point there, so we'd have to put one in, but we're going to move it to create a number between 1 and 10. And so 9.21 would be between 1 and 10. So we're going to put the decimal point right there. That gives us 9.21. And then we count over how many times we move that decimal point. And we moved it, use a different color, 1, 2, 3, 4, 5 times. So we would write 10 raised to the 5th power, but this is a fraction of 1, so we know that the exponent has to be a negative number. So we would write 9.21 times 10 to the negative 5. There are just a few things to remember. First of all, the coefficient must always be a number greater than or equal to 1, but less than 10. Secondly, numbers larger than 1 always have positive exponents. Numbers that are fractions of 1 always have negative exponents. And then lastly, be sure you count how many times you move the decimal point. Do not count the zeros. Let's work a couple of examples here on what you would do if you are given a number in scientific notation and asked to write it in standard or expanded form. So, for example, you're given the number 8.34 times 10 to the 6th power. So we are going to use the process we just described in reverse. The exponent tells you how many places to move the decimal point. And because this is a positive exponent, we know that this number is going to be much larger than 1. So we know that we have to move the exponent to the right 6 times. So let's do that. If we're going to move this exponent, we're going to have to put in some more zeros. So we move it 1, 2, we need another 0, 3, another 0, 4, another 0, 5, another 0, 6. So it's going to end up right here. So we are taking it out of that position and moving it over 6 places. That gives us a number of 34000, or 8,340,000. What if the number expressed in scientific notation has a negative exponent? Well, let's use the example of 2.71 times 10 to the minus 7th power. Ooh, that's a big number exponent. We know that this number has to be a fraction because it's a negative number. So we know that this number is going to be very much smaller than 1. We need to move the decimal point 7 places, but because we're going to make this a very small number, we know we need to move the decimal point to the left 7 times. So let's do that, and as we do that, we're going to have to add some more zeros. So we move it, use a different color. We move it once here, have to add a 0, move it again, have to add a 0, 3 times, 4 times, 5 times, 6 times, 7 times. Okay, so that ends up putting the decimal point here. We take it out of that place, and our final answer for the number in expanded form looks like this. Finally, I'm giving you 4 examples to try on your own. Please work through these, change these numbers into the form requested, and turn them in tomorrow for homework. And put the pause button on now to hold on to these. Thank you, and good luck.